Welcome to the Ground Investigation podcast. I'm Michael Taylor, and today I'm hosted by Jay Doddaballapur, an Associate Director of Ground Engineering at Jacobs. With 17 years of experience across the UK, New Zealand, and now US, Jay has worked for both consultancies and contractors on major infrastructure projects, including road, rail, deep basement, and seismic design. His diverse background gives him a unique perspective on design, constructability, and value engineering. Beyond his technical expertise, Jay is also a reviewer for the ICE and an active mentor, helping guide engineers on their chartership journey. Today, we'll be talking about his global career, the differences between contracting and consulting, and his experience converting his CEng to a PE in the US. Jay, welcome to the podcast.
Michael, thank you for having me here. It's been a pleasure.
You've worked in the UK, New Zealand, and now US. How did those transitions happen, and what motivated your moves?
Yeah, see, the UK to New Zealand transition was more of gaining seismic experience, and it was one of those things that I really wanted to kind of pursue further. And there was this opportunity in New Zealand back in 2015, 2016, and kind of like started pursuing it, and it just worked really well. And in about 6 months' time or so, like we got all the interviews and stuff sorted, the visa and what have you, and being a UK citizen, it was quite easy for me to get a visa, and it just kind of like worked out perfectly. And I ended up kind of like going into our contractors design and build team. And it was almost like a natural progression from what I was doing back in the UK, where I was working for a design company, but then they used to predominantly work on contractors' designs. So we used to take the designs from, say, larger consultants, shave off the fat, and then again rehash it and get it back to the contractor. And that way, it was more of like a optioneering or optimization experience sort of thing, which I kind of like started to build on, and like that worked perfectly well into how the New Zealand career kind of like shaped up. So that was the UK to New Zealand transition. Then like within New Zealand, I kind of like did a couple of stints, or like 3-4 year stint with that contractor, and then like went into a consulting business. And within the consulting business, um, at some point I realized that like we wanted to kind of like start being closer to family, and US was where a majority of the family was. And we thought, let's give that a shot. And Jacobs, being an international consultancy, they had quite a few openings in the US. Reached out to my current manager, and it just everything kind of like just went in perfectly well. And like he was on the lookout for somebody at a senior experience level, and I pretty much fit the bill. And like he wanted to kind of like start a numerical modeling team, which was what I was kind of like working on quite a bit. And like it just like everything kind of just fit perfectly. So it was a case of like Cinderella's shoe, and kind of like Cinderella kind of like being in there. So but then like the overall theme and like what kind of like worked out was that like 2016 Brexit was happening. There was a change in government. I ended up kind of like jumping ship. And then 2023 there was a change in government in New Zealand, and I ended up jumping ship. And then it's kind of like we love to turn our lives upside down. Let's put it that way. So that's what my sort of transitions between the countries has been.
Sure, that sounds interesting. I've moved countries a few times myself, and there's nothing quite exciting as getting to a new country and all the possibilities. Um, so, what are the biggest differences in geotechnical engineering practices across these regions? So, is there any particular contrasts or in regulations, project execution, work culture, anything like that?
Um, Probably some of the major differences could be attributed to your codes and standards. So UK and Europe in general kind of like uses your Eurocodes and Syria guides and stuff. With New Zealand, a majority of the designs are dominated by the New Zealand Building Code, and you've got the New Zealand Bridge Manual, and there are quite a few guidelines from the New Zealand Geotechnical Society called the NZGS Geotechnical modules, and designs tend to be like focused more on those. And with the US, it's whole different level of like paperwork. Um, I shouldn't be calling it paperwork, but then it's more of like you've got your federal standards, you've got state standards, you've got local standards, and you're kind of like trying to kind of like weave all of these into your project. Like there might be interfaces where you might be building something right next to a state highway or an interstate or so. So you will have your international building code sitting in there for your building, and you've got your federal highway standards or your AASHTO code sitting in there for your state highways. And it's like trying to amalgamate all of those things and kind of like trying to come up with something that is actually satisfying all requirements. So there's quite a lot in that sense to go through. So that is one major difference that I found in the three countries. In from a design perspective, in the UK, like most of the designs that I've done, like we have this thing where you kind of like, as a geotechnical engineer, you end up designing some of the piles yourself, both the geotechnical side as well as the structural side. Whereas once you come to the UK or New Zealand, or sorry, once you come to New Zealand or the US, liability is something that actually starts governing quite a bit. So there is something called a practice area. So when you're registering for your CEng or CPeng or your PE, you tend to come up with a practice area that you tend to practice in, and you generally stick to that one. So it was a bit of a change for me, like having designed piles, both the reinforcing, like say the main bars as well as your stirrups and stuff in the UK. When I came to New Zealand, when I started doing that, it was just like, oh, by the way, are you a licensed structural engineer as well? It was just some of those questions where I sort of like, it's a geotechnical structure that's in the ground. It's interacting with soil on all sides. It's something that a geotechnical engineer should be designing. But then, like, since it kind of like falls into the realm of structural engineering, it kind of like just automatically gets bifurcated into a structural engineer's domain. So that is one, and like that's all due to like how the practice area and your registration is kind of like lined up as. And if you do end up kind of like licensing as a geotechnical and a structural engineer, you can actually end up designing both. Um, in terms of like work culture, which is something that people are always asking, like New Zealand is definitely by far the most relaxed one out of the three. There's a really good emphasis and very strong emphasis, to be honest, on work-life balance. And US, as everyone knows, is quite the opposite. And I've sort of like received emails from project managers and project directors of like ungodly hours. And I've tried doing that in New Zealand once, and I got told off by my director. It's like there is a like clear demarcation where you need to draw a line. And I think the UK is somewhere in the middle. Like there are some times when you do end up kind of like having to kind of like work your bottom off to kind of like just get designs out and stuff. And there are times when you're kind of like just doing your usual 37 and a half or 40 hours. So it's a halfway house, I would say.
Sure, yeah, it depends on the culture, the size of the company,
Hmm.
where you are within that company. Because there are plenty of people here that work ridiculous hours, especially in relation to when they're a smaller company. But saying that, sometimes the larger companies work ridiculous hours. Some people just love to work, don't they? And more so than others.
Yeah, guilty as charged.
Yeah, exactly. Looking back, what were the biggest challenges of relocating and working in different countries, both personally and professionally?
So personally, I'll probably start with personally because that's something that affects you and your family quite a bit. So when you've already got a really good social circle and you've kind of like established a house and like you've got everything in a certain country, uprooting yourself is going to be hard on you, your partner, your kids, and stuff. I mean, for us, moving from New Zealand to the US was a bit of a challenge in the sense that my son, who's 4 years old, so he had actually been in the same daycare for about 3 years. And he was really adjusted to the teachers and loads of friends. And like we had daycare, like, what do you call them? Play dates and this and that and everything. And like trying to take him out from that setting, moving to a completely new country, right in the middle of summer in New Zealand to the middle of winter in the US, and then starting in a new school was a bit of a change for him. And then that again, like the new school that we kind of like got him into, like he didn't really adjust as much. So, and within 6 months or so, we had to kind of like take him out of there and kind of like go into a different school. And that definitely affected him to a certain extent, and kind of like has a repercussion and kind of like affected us as well. Um, but then from a social circle perspective, like we actually were quite lucky to have family in Boston, so which worked quite well. Um, but then professionally, I think each country comes with its own set of challenges, i.e., in terms of standards and working practices and adjusting to norms and stuff. And probably the biggest one that affected me was the whole conversions from metric to like imperial units. And you can say like there are two faces to it. Like one is basically the actual like change from projects, but then like prolonging of certain projects, which was more of a self-inflicted one for myself. So I ended up carrying a few projects from New Zealand over to the US. So I was constantly switching between metric and imperial units, which kind of like just like messes your brain up because you've been used to like decimals like tens and hundreds and thousands for like a good 30 years of your life, and then suddenly going into inches and feet and kips and pounds and stuff is like you need to rewire your whole brain and like how you function. And say like some of the widely used relationships that you use in the UK or other places, like the SPT values to undrained shear strength, which is like it's such a common thing that you use in the UK, and like it's a completely unknown practice in other countries. And like obviously like soil types are different, and like it may not correspond kind of like to the exact same soil types, but then like you're pretty much like your mind is geared up to that fact that like SU equals 4.5 N or 4.2 N for London clay and stuff, and you tend to apply it to like quite a few other places, albeit like with looking at some of your plasticity indices and this and that. But still, like you end up going to that relationship quite often, which is probably not the case in other countries. So there are certain nuances of like each country that you need to be aware of. And that's probably where the professional challenges come through.
I'd imagine if you're, converting measurements and everything, then if you're doing that later on in your workday, there's going to be so many errors. There must be, mustn't there?
I do end up having MathCAD spreadsheets and normal Excel spreadsheets, which kind of like do the stuff for me. So initially when I kind of like came in, like I just had those spreadsheets and like used to put in the metric equivalent, and it used to kind of like spit out the imperial equivalent of that. So which worked quite well. But then these days, like for the last 6 months or so, I've just been purely working on US projects, and I'm gradually kind of like accustomed to how the imperial units work and like getting a feel of what a 250 PSF surcharge would mean, which is 12 kPa for the metric side. So yeah.
Fair enough. So you've worked on both sides, contracting and consulting. What would you say the main differences in mindset, approach, and day-to-day work is?
So early in my career, I sort of switched to a contractor's designer. So even though they were a design consultancy, like they still predominantly work for contractors. So the whole the issue with like we wanted this design yesterday is already sort of ingrained into me. So it's like the fast-paced nature of construction and how you kind of like tailor your design to that. That's probably the main thing. And like with consulting projects, like generally if you're looking for or if you're working on a design for design build kind of thing, where you are going through a traditional tender process where you are the client's designer, and then it gets let out to another contractor who bids on it, and like, they come up with their own design team. So in those cases, like, you do end up having a bit of time to kind of like come up with a nice, robust design for a reference design. But then once you are part of that design and build alliance, you are effectively working with the contractor and for the contractor. So it's almost like being part of the contractor's team. So you will have quite a bit of pressure in like when to turn designs out and stuff. And like we are kind of like currently working on a project where we are turning up from a reference design, the 30% of design, which was finalized on the 10th of January, and we are submitting the 100% on the 13th of March. So it's like 2 months. We've got investigations done. We've got quite a bit of 2D and 3D numerical modeling going, and we've got a team in Poland, a team in India who are kind of like doing other background modeling on structural sides, and it's global working. So it's the fast-paced nature of design and build construction is pretty much what you generally tend to do on a contractor's side. And having worked on both sides, I think each have their pluses and minuses. If you do end up working for a contractor and like you're part of the winning team and stuff, like there is obviously some kind of a bonus at the end of the day. Whereas in consulting, especially if you're a consultant who's kind of like a publicly listed company and stuff, bonus structures are generally tend to be very, very limited to like upper management and stuff.
Okay, so has your experience in contracting influenced the way you design in consultancy? And do you think more about constructability and the cost when designing?
It's definitely, yeah. So again, this boils down to like how you actually design and how you imagine how things are getting built and stuff. And when you end up working for a contractor, you actually get to know what like things are. Like a simple example would be like, say, if you're assessing arch bridges and stuff, or say arch bridges, like carrying a railroad or something on top, and then you've got a road kind of like running underneath, and like those precast arches, like, you end up kind of like digging a trench in the ground, like putting your arch in there and backfilling and stuff. So people generally make that mistake of kind of like wishing in place the whole thing. But then when you look at it and compare it against modeling it with individual stages coming through, with each part of the backfill being modeled and stuff, you will feel and you will see that there's quite a large difference in the bending moments and shear forces that you get in those linings. So it's like knowing the right construction sequence or talking to the right person who knows the right construction sequence. And it's pretty much like since 2010, 2011, like it's probably been part of like how I design stuff. So it's knowing when to kind of like say like you don't know about it and kind of like asking the right person is probably the main thing with constructability. And at any time you're actually confused, like it's always good to kind of like go give any of the larger contractors a call and say that like, hey, by the way, we've got this project, we're looking at some feasibility studies, and like we just wanted to kind of like get an idea of how you actually construct it. So, and any contractor anywhere in the world is any day happy to kind of like give you, say, a half an hour session to kind of like just look at it. And like at the end of the day, I'm like, if you establish this relationship, it's good for both sides. So that's how I look at it.
Sure. So if a young engineer is deciding between starting their career in contracting or consulting, what advice would you give them?
So there's no right or wrong answer to this because, as I said, like you do need both parts of the puzzle to kind of like become a well-rounded engineer. That's what I think. So if you started your career in consulting, see if there are opportunities for you to kind of like go out and be on the field in terms of as a resident engineer, or even if you're in a design and build consortium, then just be on site. Or if you started your career in design, in contracting, check with your project leaders if there is an opportunity for a secondment at a design office. Like the contractor might there have their own design team, which most of the large contractors in the UK, US, and Australia, New Zealand do. Or if you are in a D&B partnership, then you can kind of like get seconded to your design joint venture. It's definitely good to understand both sides of the story.
Struggling to find top geotechnical and geoenvironmental talent? You could use a generalist recruiter, or you could use a specialist. At Geo Expert Search, we place experts where they belong. Across the UK, USA, Australia, and New Zealand. No highways, no bridges, no structures. Just geotechnical and geoenvironmental. Now and forever. Geo Expert Search. Finding the right people for the right roles with no wasted time. Visit geoexpertsearch.com to learn more.
Sure. Okay. So you've led geotechnical design teams on a wide range of projects. What's been the most technically challenging project that you've worked on and why?
Um, too many to list, to be honest. Like, where do I start? Something in recent memory. We had a large slip in West Auckland back in 2023, 24, when we had some, or maybe 2022, 23. We had some like I think 1 in 100 year rains or something, and we had quite a lot of slips that happened. And this one ended up taking out one of the tracks on one of the main lines there. And so we had to mobilize under a very, very short notice, get investigations done, get lab testing, and get a full design sorted. And this was again like in a span of like 2 to 3 months, we had to kind of like go through from optioneering all the way up to construction. And the challenge in there was that the slip had not fully moved. I'm like, it had kind of like formed a 2.5 meter scarp face at the very top of the embankment, but then the entire mass had not actually fully slid down. There were some parts which are slid down, like it was kind of like just all a big lumpy block. But then there was no huge bulging at the toe, which you'd find in a large deep seated failure. So it was that really tricky situation where we had to create an access road for the piling rigs to go through so that they can install the remedial measure, which was basically an anchored sheet pile wall. And we had a micropile A-frame along the bottom part of the slope to stabilize that part of the slope. So trying to get the whole solution in and doing both temporary and permanent works design in the same go. Um, and working with a team which was based out of New Zealand, Australia, Philippines, India, and having a peer reviewer, which was like another consultancy within New Zealand, and trying to kind of like tie all these loose ends together, working across different time zones. That was probably, I wouldn't say extremely challenging technically, but then it's like the coordination part of it is probably where the challenge is. Um, it's again, each project has its own sort of challenges, I'd say. But this is probably the most recent one that I can talk about. There are others which are confidential, of course, which had more complicated issues, but then I can't obviously talk about them.
Sure, that's fine. You talk about the kind of organization and time zones. I mean, when you know, I work in UK, Australia, USA now in terms of the recruitment. And yeah, you constantly having to check what time is it there, what time is it here, okay, and then it's a slightly different person that's in the meeting because they're in a different office in the same company, so you have to kind of coordinate. It just get confusing, and I'm not even doing the kind of the geotechnical actual project management and everything else that you're doing. So yeah, I mean it's a tricky world to do business over different time zones, I think. Seismic design is a big part of your expertise. How has your experience in New Zealand shaped your approach to designing for seismic resilience in the US?
So this is almost like an intertwined story because geotechnical earthquake engineering is sort of driven quite heavily by research in the US, um, quite a bit in New Zealand and Japan. You can probably say that this is like the holy trinity of earthquake research. There are quite a lot of good research coming out from other universities as well, but then like a majority of the stuff that gets incorporated into standards is generally from these countries. And with New Zealand, there's quite a lot of cross collaboration with the US and Japan. So you are normally quite abreast of like what's happening in the other parts of the Trinity. So a majority of the designs that we do tend to kind of like follow some of the regulations from the FHWA or from AASHTO and stuff, like which was what the case is in New Zealand, in the US. And some of these standards do end up having parallels within the New Zealand Bridge Manual. So the AASHTO Bridge Manual and New Zealand Bridge Manual kind of like generally have quite a few parallels in there. And then like New Zealand, there are certain things for which New Zealand doesn't have a standard. So people tend to use quite a lot of American standards for use. Like, say, for example, soil nails and stuff, generally either, depending on where the engineer is from, you tend to kind of like go with Syria 637 or BS 8006 if you're from the UK, or if you're from the US and you go with like FHWA GC 11 or 12 or whatever that number is. So it's like based on people's experience and like how they kind of like go through with that. So that way, I'm like the whole earthquake geotechnical community does end up having quite a lot of parallels, which kind of like work quite well seamlessly. So I wouldn't say there was a huge transition or a jump that I needed to make from my New Zealand experience to how I'm applying it in the US. And then like the good thing for me in like not adding to the complications is that my exposure to the West Coast projects has been fairly limited in the last year. I mean, I'm working on a couple of projects, but then not as much as what I wanted to. So which has kind of like meant that like I'm focusing more on the static design. But then even in static design on the East Coast, we do need to kind of like check some of the seismic effects. Couple of projects in Boston, like we were in probably the worst possible soil conditions in Boston, where we had about like 30, 40 feet of marine sands and silts, and then going into very soft clays. So from site class perspective, we were almost on the border between site class E and site class F. So the moment you go into site class F, you generally tend to kind of like start going with a probabilistic site-specific hazard assessment and stuff, which is like it's probably the most extreme kind that you can actually ask for in Boston. But then like we do end up having those cases as well. But then we managed to kind of like get some investigations done as well as testing so that we kind of like avoided site class F. But it's like I do a bit of seismic work in here, but then not as much as what I was doing in New Zealand. But then the West Coast projects do tend to have like quite a bit of modeling using advanced soil models like PM4 sand and PM4 silt, and quite a lot of earthquake time histories and stuff. And so that still keeps me busy, but then not as busy as what I used to be.
Sure. Okay. So you've worked on some projects like Logan Airport or Logan's Airport runway extension and other Middle Eastern projects. Can you share some insights into the geotechnical challenge on those?
See, numerical modeling is where most of the challenges sort of like come through, especially with dynamic problems. And most of the time, it's like calibrating your models against a certain um, say stiffness degradation. So with dynamic models, what we tend to use is like degradation curves, which were done back in the 90s and 2000s by quite a few authors, and they are included in a software called Deep Soil. So we tend to use say a Darendeli or an Andrus and Anderson Stocco. There are quite a few curves that we tend to use, and we tend to calibrate how your shear strain degrades or shear modulus degrades over shear strain. So trying to get that degradation into Plaxis or FLAC and for varying materials, and trying to train people up to actually do that stuff is probably where the hardest part is, because the team that I had was basically an engineer set of engineers from India, Australia, and quite a few other places who definitely had no experience prior to that on dynamic modeling. So it was like the whole educating them on how to do the analysis part, which was quite challenging in that sense.
So you're a viewer for the ICE and an active mentor. What drives you to give back to the industry in this way?
So during my younger days, like I've seen several of my seniors kind of like mentoring me, as well as like quite a few of the other engineers in the teams. So and as you kind of like start growing in your career, it's almost like a moral responsibility of kind of like passing that through, and like you're kind of like putting that good karma through in motion. So that is how it is. And like and the main thing in there is every time I review a report or every time I review a CPD sort of record, it's like you actually learn something new. So somebody who I haven't actually supervised, say, like as a mentor, like I used to get reports from like people working for other consultants, and like we used to have a mentoring group, and it was just like right, like people have actually done these, or like I mean, it may not necessarily be geotechnical engineers, but like other structural engineers or even construction guys, so like who've actually gone down the ICE route or the Engineering New Zealand route. It's like, oh, by the way, I'm like, that's another way of analyzing stuff, or like that's how they actually constructed this, and like that's how they've mitigated against safety hazards on site and stuff. Like it's you are adding to your body of knowledge every time you read a report, or every time you read something else that's coming in from somebody else. Like different perspective, different experience, it all counts at the end of the day.
It's a great way to kind of cement your own knowledge as well. If you have to
Exactly.
teach, it really forces you to bring out the, bring out the concise way of putting it all across and doing that. So, what are the biggest knowledge gaps in geotechnical engineering today? Would you say?
You're putting me on the spot here. So yeah, I wouldn't really call them knowledge gaps, because I think most of the universities that are teaching geotechnical engineers, or the next generation of geotechnical engineers, are doing a fantastic job. And so I would say it's more of application of theoretical knowledge into practical applications. So it's something that you build over time, like through experience, but I wouldn't necessarily call it as a knowledge gap. But something that I've seen young engineers do, and I do once in a while as well, it's like attention to detail, or kind of like going and back checking your own work. And like I think everybody is guilty of doing that at some point. Like, you do end up getting complacent, like having done the same calculations like 100 million times. You kind of like just go on autopilot mode and you just do it, and like you just realize like, and somebody kind of like looks at it like a couple of weeks later, and you end up kind of like doing that. So it's like don't rely on your seniors as the line of defense, but go ahead, check your own work, check it twice if required, and then before you kind of like put it onto your seniors. So that's probably one um, vital piece of advice that I can give to anyone coming up the industry.
So do it once, check twice, I think is a good kind of rule of thumb for most things, really. Saves
Yeah.
saves on a few mistakes. So if someone's working towards their chartship, what are some common mistakes that you've seen candidates make, and how can they better prepare?
Okay, so this is something that I've seen quite a few times, like peer pressure. Somebody did their C Eng in like 3 years, and or maybe 4 years, let's say, and I actually want to kind of like go through with that. Like sitting your review too early is definitely not a good thing. And everybody is on their own journey path, and you might be on a 3 year path, and like somebody else might be on a 2 year path, somebody else might be on a 6 year path, and how you structure it is up to you, and you don't need to kind of like succumb to peer pressure. And so I've seen reports where people have kind of like had glaring mistakes in there, and it's like, why don't you kind of like give another 6 months to it, or maybe another year? And there are certain aspects in here, you've demonstrated depth of knowledge in one particular aspect, but there's no breadth of knowledge at all. Like every single design that you've done is effectively the same thing, and you can't be kind of like just putting the same thing over and over again. So try to kind of like broaden your experience. Like you might need another 6 months or maybe another year to kind of like look at certain other parts, but don't set it too early. Health and safety is probably another big major one. So I've seen some glaring issues in health and safety side of things. Like people have posted photos where they've got excavations, like almost near vertical excavations with like unsupported sides and stuff, and like people taking photos from the top of it. It's just like, you really don't want to kind of like put those things in your CPENG report and not talk about them. Like if you are putting it in, you might as well at least say that like I kind of like ensured that the contractor uses some kind of a trench box or a trench shoring kind of thing to prevent any sort of safety hazards and stuff. And it's one of those things where not thinking about like what the end result would be and stuff. Um, the other thing that people generally tend to ignore is independent judgment. Knowing where to kind of like draw the line and ask for help and stuff, and like demonstrating this aspect is always quite difficult. And it's like based on experience, you will obviously gain it, but it's just that like how you demonstrate it in your report is what kind of like, because reviewers would be kind of like looking at every single one of those 8 or 9 objectives and seeing whether you've ticked off some of them, or if you haven't, then you at least need to demonstrate that in your professional review on the presentation day. So yeah, I could probably list 3, but then there are quite a few others as well. But I think these 3 you could consider the major ones.
Let me just ask you this then. In terms of the kind of peer pressure you were saying about chartership, do you think some companies are guilty of, just trying to push their staff into it quicker just so they can have the, chartered members of staff, which looks good for their company?
I really can't comment on that. But see, I mean, like, I worked for large consultancies in the UK, and even in New Zealand, and now in the US. And never ever have any of my managers actually pushed me to kind of like go right and like, you need to kind of like do it in 3 years, otherwise you won't be getting a promotion to a senior engineer or something. I never had that peer pressure. There were a couple of people who ended up kind of like getting it in like 3.5 or 4 years, and like excellent. But I was on my own journey, so it's like you need to take a stand on kind of like saying, right, no, like, this is how I'm kind of like preparing for it. I intend to kind of like sit this in like 2 years time. Like I wanted this experience, I'm focusing on this, and the next experience or the next part is something that I want to focus on the next 2 years. So it's trying to kind of like, I wouldn't say put your foot down, but then at least kind of like standing for yourself and saying, that's my journey, and like I want to kind of like take it this way. Yes, and like it might affect me in certain parts, like, but let's see. So
Yeah, no, I've worked for some companies before, and I think it's 5 years or 4 years with a master, and they were quite keen for you to kind of get it done as soon as possible. However, there's also other people that have been there for 20 years. They hadn't got it done, and they were trying to go back in time and remember what they would actually done to go towards, you know, an actual chartership. So it's different. It's different for each company. So you originally became chartered in the UK and hold a CP Eng in New Zealand. Now you're in the US. Have you had to? Sorry, you've had to convert your qualifications to become a professional engineer, PE. Can you talk us through that process?
Yeah. So the UK one was well, back in 2014-15, and that was through the old scheme where I had to go through the entire the professional development and kind of like do all the development objectives, and then wrote an experience report and a project report, and then kind of like went through my review. So and following that, when I moved to New Zealand, Engineering New Zealand had a 2 to 3 year mandatory local experience requirement, and I'm pretty sure it's still there because you don't want somebody coming in from a different country not having known what the regulations are, what the local practices are, and signing off engineering drawings and reports. So it was 2 to 3 years of demonstrating that you've got adequate seismic experience, and that is what I did. So like 3 years, I think I got it. Yeah, I think 3 years. So it was pretty much showing some liquefaction experience, lateral spreading, and like quite a lot of seismic retaining wall experience. So it's basically just doing every other thing that every other geotechnical engineer in New Zealand is doing to get their CPeng. And so on that, after that rather, with the US, I started researching about how to convert my UK or New Zealand registrations to the US once I started talking to the Boston office. And I knew that like Idaho, one of the states in the US in the Northwest, they already had a reciprocal agreement. And so that was one that was already ticked off for me. And then Pennsylvania as well as Nevada again had reciprocal agreements. So those are the 3 states. And then so I'm still kind of like going through other states as well. But then I already knew about a couple of states before I came to the US. So in terms of the actual process itself, you have something called the NCES, which is one of the local governing bodies. I wouldn't call it a governing body, but then like uh, it's a body which kind of like administers some of the professional engineer and the fundamental engineering exams, and they have something called an NCES portfolio, wherein you put all your educational records, you get your official transcripts from your universities, get some recommendation letters or reference letters from your current and previous managers, and you get what else is there? So you've got a project summary, and like, you need to demonstrate that like you've done 5-6 years of like experience under a professional engineer supervision, and you've taken like gradual increases in responsibility. So you put that portfolio in there, like NCES evaluates, and then they kind of like say that like yes, like, you've got an NCES record which can be sent out to other state boards. And once you end up getting that, like you send it to a state board and like along with their actual application, and they process it. Like state board kind of like goes through their own set of monthly or quarterly meetings, and like once they say that like yes, like he's basically got a UKCN, he's got an NCES record, which again says that like he's ticked off all the objectives. So it's almost a reciprocal equivalent of state PE, and then like they just put the tick mark, and then you get your certificate. So it's a long-winded process, but then it's definitely worth it.
Excellent. Okay, so I've just took one of the questions out because I feel that you answered it in the reciprocal agreements, apart from the additional 24. But I think you answered most of that question, so I've taken
Yeah,
that.
but just to add to that, I think so that agreement was signed back in August last year, and I think there are about 5 or 6 states that have signed up to it at this stage, and there are another 20 states who've sort of put an approval in principle or an agreement in principle, but they need to again go back in. They need to amend their regulations, and all the state board members need to approve that like unconditionally before it actually gets ratified into their state constitution. So it will take a bit of time, but then there are some states like California, Washington, Oregon, like Utah, and there's Washington D.C. perhaps, and like a couple of New England states. So there's quite a few states that have actually agreed to kind of like go through with this.
So, for internationally qualified engineers looking to move to the US, what advice would you give them about securing their PE? Are there any specific challenges that they should be aware of, for instance?
The NCES thing is probably the biggest one, I'd say. But then getting a CEng is probably your first step. CEng, and then like you need to have an NPE as well, International Professional Engineer, which is again something that you apply with the Engineering Council. Once you've got those two, it's effectively creating your NCES record and going through the whole process and applying to the state that you want to. But again, like if you are moving to one of the New England states or maybe in the southeastern states and stuff, and if you are getting a PE in one of the northwestern states, it might not actually work for you in that sense. But then it's like depends on like where your company actually works, and if your company is like based all over the US and you do end up getting involved in like projects across the US, then yes, like it's worth getting a PE in a different state to where you actually live. But then most people tend to kind of like get PEs in the states where they've actually got projects.
So, with 17 years in the field, where do you see the future of geotechnical engineering heading? Are there any emerging trends or technologies that particularly excite you?
Yeah. Artificial intelligence and machine learning, that's something that'll definitely get incorporated quite a bit more over time. And where it's kind of like going, I would say it's you still need an engineer with engineering judgment to check what these models are predicting. But a majority of the routine calculations that you do can definitely be done by tools that are already existing, or you might need to create a few custom tools to kind of like look at how things go. And machine learning, in terms of like the wide application of it, I mean, say one of the examples, like the assessment of like previous pile test data, that's something that you can definitely train a machine learning model to learn and predict what's going on. And I think like if you're working on a project where you've got like say 300, 400, 600 pile tests, and you need to kind of like crunch all that data, an ML model is actually a perfect tool for doing that. That is one. Your programming interface for quite a few software, linking them together. One of the things that is working quite well in like Jacobs and quite a lot of the larger companies is how they've integrated Excel-based spreadsheets or inputs in Excel-based spreadsheets taken to say Civil 3D or so, and then with a Dynamo interface that kind of gets exported over to Plaxis or FLAC. So if you imagine a situation where you've got a linear embankment or a railway kind of stuff, you can cut your cross sections, you can input your parameters, you can get all your layers and everything, export everything into Plaxis by the click of a button. And Plaxis actually runs and kind of like spits it out into an Excel spreadsheet again. So all of this at the click of a button. But knowing whether those results are garbage or the right numbers is where the licensed engineer sort of comes in.
Yeah. Well, I hope it's better than ChatGPT, because I was working out yesterday a time zone, and somehow it got it wrong. Seems such a simple thing. It's definitely not good when there's numbers involved. So yeah, I hope it's a little bit more advanced than that. Excuse me. So one last question now. If you could go back and give your younger self some advice at the start of your career, what would it be?
Probably the biggest one is learning when to say no. And I still haven't learned that, to be honest. But if I wanted to kind of like focus on one point, it would be that one. It's like you just kind of like end up taking quite a lot on. And like it's just the nature of the projects. And like if there is an important or really interesting project, you actually want to be on it. And that is where it is. Like you've already got a 40-hour plate full, and you still end up signing up to projects, like, which is where things actually go out of hand. So something that I've done quite a bit more proactively over the last 3-4 years after the birth of our first and the second kids and stuff. But I still kind of like fall into that trap once in a while. But then if I could have kind of like reset back, like say 15, 20 years back, I would have probably said that's probably my first one. Second one, I think the way things are being, or the way things are going at this stage, a bit more programming knowledge would have actually kind of like been really good. I've been kind of like doing quite a bit of programming off late, but then it's all kind of like out of our sort of learning and stuff, which tends to affect your social life and this and that. But then it's just one of those things, like you need to kind of like keep pace with like how the market is going and how the new grads are coming out, because everyone these days is coming out with like R and Python and C++ and Visual Basic, and like, you basically gonna ask them to do something, like you've already got a script kind of like in front of you that does that. So it's like reading that script, debugging it, and kind of like saying, right, like we can actually adopt it in our routine practice is probably where the whole thing sort of like comes in.
Okay. Okay, so don't be project greedy then, is what you're saying
Exactly, yeah.
today. Right, Jay, it's been fantastic having you on the podcast. Your experience working across different countries in both consulting and contracting, and your dedication to mentoring makes for an interesting journey. Thanks for sharing your insights with the listeners. And for our listeners, if you've enjoyed this episode, please don't forget to subscribe and leave us a review. Thanks for tuning in to the Ground Investigation podcast, and we'll catch you in the next episode. Jay, thank you for your time.
Yeah, thanks for inviting me. It's been a real pleasure talking to you.